Wetlands play an immensely important role in the protection of our coasts. They provide for and protect surrounding lands by acting as a buffer between coastal and inland areas, aiding in the maintenance of water quality as well as the prevention of erosion. However, sea level rise brought on by climate change has and will continue to put stress on our coastal wetlands. The saltwater intrusion brought on by sea level rise can alter the biogeochemical properties of coastal wetland soils, altering the effectiveness of ecosystem services that it provides. My research focused on how coastal flooding events alter the properties of soil water, with an emphasis on how soil colloids affect salinity levels as well as levels of dissolved phosphorus. These soil colloids have very small particle size, but also have a very large surface area. Due to this, the presence of these soil colloids can affect the transport of elements like phosphorus. Pore water samples from St. John's Reserve in Dover, Delaware were extracted from 4 sites with varying distances to the shoreline in an effort to characterize a salinity gradient. These samples were also extracted via a peristaltic pump and purged with argon gas at 30 and 120 centimeter depths. The collected samples are centrifuged at varying speeds and times and then separated out into several size fractions. The smaller the size fraction, the length of time and speed of the centrifuge is increased. The size fractions were separated out in an environment where no oxygen is present, as the presence of oxygen can disrupt the sample's physical and chemical properties. To separate the smallest size fraction, the sample is filtered using an ultrafiltration system. A reagent is then added to the samples, causing a color change. This change in color is quantified using a spectrometer, and the absorbance of samples are measured. The darker color blue indicates a higher concentration of dissolved phosphorus. The results of my research will be beneficial in understanding the relationship between salinity and phosphorus in wetland soil, so we can be better prepared for the changes our coastal marshes and wetlands may face as sea levels continue to rise.